Respond.
Yes.
Definitely, we need to know the alphabet.
Yes, sir.
Without alphabets of ABCDs, if English ABCD, you can't learn the English language. Similarly, you can't learn Marathi or even Kannada also. Okay, you can't without alphabets of Kannada, you can't learn the Kannada language. Without alphabets of Marathi, you can't learn the Marathi language. Of course, you can make speak, but it is difficult for us. If anything is written on the board, you can't read that one. So before, isn't it? Learning any language, you need to learn the alphabet. Similarly, isn't it? Learn the periodic properties, this periodic table, or anything about the chemistry, we need to know about the elements here, isn't it? This is the alphabets. A for apple. When you go to what LKG, UKG, they don't, isn't it, explain what is something poems like that, something what happened English, everything. Don't say explain the novels for you, isn't it? Or something lessons for you. Just start from where A for apple, B for what ball, like that. What happened? They teach you, isn't it? Similarly, what happened in chemistry also, we will teach chemistry with the elements only, starting with the elements only, isn't it? Without elements, there is no chemistry, isn't it? We have to start from the, isn't it, elements. So based on the fact that some scientists considered chemistry as a language and periodic table as its alphabet. So for English, alphabets are A, B, C, D, E, F, G, H, like that. For chemistry, this periodic table is the alphabet chart. You have seen some chart here, isn't it? This chart for what? Actually for English language, isn't it? Similarly, for the chemistry, this is a chart, isn't it, which provides the everything about the chemistry. Periodic table is nothing but an ABCDs of what? Chemistry, isn't it? So we put, before learning things what happen, we should know how they are arranged here, why they are arranged like this, isn't it? They arrange the elements in a different manner, like atomic number and groups, periods, everything is given in this, isn't it? So let's see each and everything now. Now, if you want to learn the periodic table, we should know how it is developed. See, this is a child developed from the, isn't it, infant to what actually a young man like this. A common growth of the human being in this manner, isn't it? Similarly, what happened? The periodic table also what happened? Gradually, it is what developed here. So, in the same manner, there is a gradual growth in the chemistry with the discovery of element. Whenever element is discovered, whenever element is invented, so the growth of the chemistry, the development of the periodic table was completed, isn't it? So when you do one, observe one thing, in 1800, that only what 31 elements are there. So based on 31, they made a chart. After 1865, the elements are increased to 63. They made one more chart called Mendeleev periodic table. So some improvement what happened in this one. At present, if you observe, there are actually 118 are there, but 118 are there, but still their properties are unknown. Okay, so remaining 4 elements properties are unknown. Why? Because they're actually invented. They're artificial elements. Whatever after the uranium, all elements are actually artificial. They are made in laboratory. Okay, they are not natural elements. So their properties are unknown. We are having 118 are there. Okay, but still their properties are what? They're getting that property, they're developing their properties here. So we are having 118 elements are there. Okay, we are having 118 elements are there. Now, understand the properties of the elements easily. So if I say what happened, all of you have to explain the elements, and all 118 elements you have to explain tomorrow. What you say, what happened? Is it possible for you, or is it easy for you? It within one day, learning all the elements properties, easy or difficult for you? Tell me.
Sir, it's difficult.
Very difficult. Learning what happened, each element differently, each element separately. If you learn what happened, very difficult. Learning the properties of the hydrogen separately, learning the helium separately, like that, it will difficult for you. So if you do one thing, what happened, whichever elements are having same properties, Okay, put that one in a group, and if you remember that group properties, you will know all the properties of that elements here, isn't it? Whatever the group elements present in that group actually. So what I mean to say is that to make easy for us, okay, they they classified the elements systematically actually. In that systematic division, what happened, we are having what actually different type of tables are given actually. So after what is the need? What is the need for what classification of element? After studying this chapter, what happened? What you are going to get? Okay, if you read this chapter, what you are going to learn? That if you observe what happened, you can understand the need for classification of element. Why we have to classify the elements. Second thing, we can understand the present form of the periodic table. How the what periodic table we are actually using here, and we can classify the elements based upon the SPDF blocks actually. So this SPDF block, only 4 blocks will be there: S block, P block, D block, and F block. What is this block? We'll discuss in the next slides actually. We can understand the properties also. These are the objectives generally we'll get after studying this chapter actually. So let me see the genesis of this periodic classification. At present, there are 114 or 118 elements are there. We can take 118 elements. It's very difficult to study all these elements at a time. Okay. Now, so as to understand the properties of the elements easily, they are classified systematically. So all these 118 elements, they are classified systematically. Now we can learn very, very easily. First one, you know, this one you have studied in the 10th class, Dauber-Inner law of triad system. I don't explain this one. So the first classification is what? Dauber-Inner's law of triad. This is the already you have studied in the 10th class. Newland's law of actives, isn't it? Like a Sarigama Padani, you're having what? Newland's law of octaves. The second. Next, Lothar-Meyer periodic table is there. Next, Mendeleev periodic table is there. And now we are studying what happened, modern periodic table. So all these 4 you have seen in the 10th class. In the 10th class only. So, and actually you are having in the 11th class, but they reduce the syllabus. So this is no need for us. I don't discuss about these topics. I will directly go to what? Modern periodic table in detail we study here. In detail we can study now. Not there in the portion, leave it this. Already I have studied in the 10th class also. So we'll see the modern periodic table actually, isn't it? So what is this modern periodic table? Let me see now. Now, who proposed this modern periodic table? Moseley. He proposed the table actually. So the first thing, who proposed it is, his name is actually Moseley. Now on which base he classified the elements? What is the basic point, isn't it? To classify the elements. Anybody? Which point he has taken to classify the element? Respond to.
Atomic mass. Number.
Atomic mass has taken criteria by the whom? Mendeleev. Mendeleev taken the atomic mass as a criteria, but
atomic number.
Abnormal mass, they are getting some contradictions are there, some limitations are there. To overcome that limitations, Moseley proposed a periodic table based upon the atomic number. Now, how we have taken atomic number? How we got atomic number? For that, he has done an experiment. Let me see that experiment now. How he done an experiment actually. So, atomic number generally represented by Z symbol and X-ray. You know, X-ray everything, X-ray radiation. Now, so he had a relation between the frequency of X-ray. This is the frequency of X-ray, and Z is the atomic number. A, B are the constant values. They are constant. So he observed there is a relation between the frequency of X-rays and the atomic number. That means different atomic numbers are different frequencies here. So based upon the frequencies of X-rays, he proposed the, isn't it, this model. Let me see that one in detail by a graph actually. I will take a graph here, atomic number and X-ray frequency. The frequency of X-ray I have taken the root value. I have taken the root value I've taken. Now what happens here? He got this type of graph here. Okay, this type of graph. As a, isn't it? As a frequency is what happened, increasing the atomic number. Also what happened? You see, frequency is increasing and atomic number also what happened? Increasing. So he has identified a relation between the atomic number and, isn't it, frequency, square root of the frequency he actually observed. Something is there between the frequency of X-rays, isn't it, when they passed on the atom. So he got something is there, something relation is there actually. So based upon this relation what happened, isn't it, he proposed this theory. This is actually graph he got actually. So by this he concluded that the atomic number is the fundamental property of an element, then atomic weight. So this is the fundamental. Atomic number is the fundamental. If you observe what happens, some contradictions are there here. Atomic weight, no, it is atomic weight, no. So you see here, isn't it? They are having same. We can't identify here. No relation here. Here there is no relation. But in the previous case, see, the changing with respect to frequency, the changing, the numbers are changing here. So that is the reason what happened. In place of atomic weight, isn't it, best to take what here? Atomic number, isn't it? The atomic number is the fundamental property, isn't it? So based upon what happened, whatever the limitations of the Mendeleev periodic table, now what happened, rectified, isn't it? So what is the modern periodic law? This is very, very important thing you need to remember. Our topic starts from here on. Examination point of view, they ask what is modern periodic law. So what we have to give? What is modern periodic law means what we have to write. What is the definition of the modern periodic table? So here the physical, chemical properties of the element are periodic functions of their atomic numbers, or you can take electronic configurations. Okay, electronic configurations are atomic numbers here. So what is the meaning of this one? Physical and chemical properties of elements are periodic functions of their atomic numbers and electronic configuration. That means what is the meaning of this one? By changing the atomic numbers or by changing the electronic configurations, their physical chemical properties are also changing. That means these physical chemical properties are depending upon what actually? Atomic number or electronic configuration. The meaning of this one, the physical chemical properties are depending upon their atomic numbers and electronic configurations. So simply we can say their periodic functions. How they are changing? What happened? In periodic functions here. In their periodic function, repeatedly they are what happened? Changing. Repeatedly changing. I will show in the modern periodic table how they are repeatedly changing. So all of you, what happened? Note down this one. Note down this statement. Give the statement of what? Modern periodic law. What we have to write? The physical and chemical properties of elements are periodic functions of their atomic numbers or electronic configuration, isn't it? This statement you have to write in your notebook. Very, very important statement. Next, how it looks. This is the actual, isn't it? Modern periodic table. So I have taken, this is the old one, but actually we are having up to 118 is there. So nomenclatures are there, but we'll change that one. From here also we are having any number of. So this is the old. Actually, this PPT is old, no. So 111, 112 names are there, but I will show that one in the next slides. Okay, this is also we can. This is actually what modern periodic table, also called long form periodic table. Now here, if you observe what happened, atomic numbers you observe here: 3 to 4, 5 to 6, 7 to 8. Atomic number is increasing. Now, when the atomic number is increasing from left to right, okay, from left to right, atomic number increasing or not? Yes. From where? 3 to 10. Now, what about the periodic properties? Size, what happened here? Decreases here. Left to right, size decreases, ionization energy increases. That means some periodic properties, what happened? Changing. Similarly, from top to bottom. Top to bottom. Size, what happened here? Increases. Top to bottom. As atomic number changes, what happened? Size, what happened? Increases. Ionization energy decreases. Like that, what happened? The periodic properties, what? Depending upon what actually? Their atomic number actually, isn't it? Now, each and everything we'll discuss one by one, isn't it? Let me see the. Now, let me see how many periods are there here. Now, first of all, what is period? First of all, what is the meaning of period? Horizontal row is called what? Period. This is the horizontal row. Horizontal. This is called what? Period, isn't it? Which period is second period? This is the first period. This one is the second period, third period, fourth period, fifth period. This one is the sixth period. This one is the seventh period. Is it called eighth period? Respond. Is it ninth period? How many periods are?
No, sir.
Total, how many periods are there?
7.
7 periods.
Only 7 periods you are having. English is there. The daily English period is there. No, not there. आपको नहीं है daily English. Okay, no problem. So there are only what? 7 periods are there. But what about this one? These are actually what? Lanthanides and actinides. These comes under 6th period. Lanthanide comes under 6th period, isn't it? Actinide comes under 7th period. Then you will get a doubt actually. Why don't you include this lanthanide here only? Because it's a 6th period. Okay. After 57, 58 is there. So why don't you include here 58? Isn't it? 57 next will be 58 only. No. But what they taken 72 they taken, isn't it? Why they taken 72? Because if you place 58 to 71 here, you are getting some disturbance here. Periodic properties are not changing, isn't it? Periodically their properties are not changing. What happened? Something what happened? Increasing and decreasing like that. So they are getting some contradictions. They are getting. The periodic table is getting disturbed here. So that is the reason they kept bottom. Okay. So you cannot place lanthanides between the, isn't it, 57 and 72. You can't place in the middle of the periodic table. It is impossible. Why? Because if you place what happened, you are getting what actually some difficulties to learn the periodic properties. That is the reason separately they placed 6. Similarly, what happened? The 7th period. This is the 7th period. In 7th period, you are having 87 to 118. This is 118. I am writing here 118, 117, 115, 113. Okay, right. So in 7th period, you are having what? Up to 18. 32 elements are there. Here you are getting what? 18. And here you are getting what? Something again? 14 here. So you are getting 32 elements. Here also same thing. If you place 90 here, what happened? The periodic table is getting disturbance here. So why it is getting disturbance, I will explain everything when you discuss about lanthanides and actinides. Okay. So what I mean to say is that period is what? Horizontal row. This is line, horizontal line generally called as a period. So total how many periods are there? Total 7 periods are there. Okay. If 119th element, if we discover that, if we invent that one, then we can start 8th period also, isn't it? So until now we are having only 118. So we can make only 7 periods only. Now what about the groups here? It consists 7 periods which are horizontal rows generally, isn't it? Now what about the periods, the groups here? So these are the group columns. Columns generally called as a rows actually. There are 18 groups are there which are called vertical columns here, isn't it? They are called vertical column. This is a vertical column. vertical column like this, isn't it? This is a vertical column. This is called first group, second group, third group, fourth group, fifth group, sixth group, seventh group, eighth group, ninth group, 10th group, 11th group, 12th group, 13th group, 14th group, 15th group, 16th group, 17th group. 18th. Now lanthanides will comes under which group? Anybody? Lanthanides are which group elements?
Sir, 6.
Which group? Sixth. Now tell me, after which element a lanthanides are starting? After which element, atomic number? Lanthanides are
Fourth.
So fourth group.
Fourth.
After which element lanthanides are starting? My question.
57, sir.
After which element lanthanides are starting?
So after 57.
57, sir.
Your answer is what? 57, right? After 57 or after lanthanum, lanthanides are starting. So all lanthanides are belongs to third group only. They are not fourth group. Remember, it is third group only. Third group consists how many elements? Scandium, yttrium, lanthanum, cerium to what? Lutetium. Next after that, actinium. Thorium, if you observe, thorium starting after what? Actinium. So both lanthanides and actinides, they are belongs to which group? Third group only. It is a third group element and it is also third group. Now tell me, which group contains highest number of elements? Which group contains highest number of? Third group. How many? How many? How many there? Count karo.
6.
So 32.
Remember one thing, lanthanides are having 14, actinides also having 14, and here it is having 4. So you are going to have how many? 32 elements. So third group is having, how many elements are having? 32 elements are there in the third group. Now, which period is this longest period? Which period is the longest one? Which period is the longest one?
So 6th and 7th.
Both 6th and 7th longest periods, isn't it? 6th period contains how many elements you observe? This is the 6th period, no? This one is the 6th period. How many elements it is having? 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now what about this one? This also what? This lantern is? Which period is this? 6th period. How many are getting here? 14. Total 6th period contains how many elements here? 32 elements. Even 7th period elements are also having 32 elements. Both 6th and 7th periods are having highest number of elements. That is what? 32. Okay. Including lanthanides and actinides. So now what I mean to say is that lanthanides are, see, lanthanides are which period? 6th period. Okay, 6th period. Which group they are? Third group. Similarly, actinides. Which period they are? Speak out.
7th.
7th period. Which group they are? Third group.
Third.
This is
7.
important. Remember this one. Very simple concept. Okay. So I have completed what is the meaning of group and what is the meaning of period. And how many groups are there? 18 groups are there. And how many periods are there? 7 periods are there. Now I will explain one more thing here. You can also give group number according to the, isn't it, Mendeleev periodic table. This is the group number I given, no, 1, 2, 3, 4, 5, 6. Actually, they are actually according to the modern periodic table. According to the modern periodic table, according to long form periodic table, we are giving 1 to what? 18 groups actually. But according to the Mendeleev old nomenclature, this first group is called first A. Second group is called second A. This third group is called third B group. It is called third B. This is called what? Fourth B group. This one is called fifth B group. This one is called sixth B group, isn't it? This one is called seventh B group. This one is called, all these are called eighth B group. All these means what? 8th, 9th, 10th, they are called 8th B group. And this one is called what? First B group. This one is called second B group here. This one is called third A. Fifth A. Is first A, second A, fifth A, fifth, seventh A. Is there any reason is there? First A, second A, third A, fourth A, we are writing no A and B. Any reason is there? Now, if you observe what happened, this first A, second A, they explains the valency electrons. To know the valency electrons, isn't it? Outermost shell, how many electrons are there, that it can be explained here. Okay, NS1 configuration, NS2 configuration, NS2. For example, I will take only one sample here. Okay, first A group. It will have NS1 configuration. That means 1s1, 2s1. For example, potassium. Outermost configuration will be what? 4s1. We take francium. Outermost configuration will be 7s1. So this one indicates it is a 1A group. 1A group. For example, I will take what here? 15th group. I will take 15th group here. 15th group is having NS2 NP3 configuration. NS2 NP3. That means nitrogen will have what type of configuration? 2s2 2p3. Phosphorus will have 3s2 3p3. Bismuth will have 6s2 6p3. Now total number how much here? 2 plus 3. If you add these valency electrons, 2 plus 3, how much you are getting? 5. So fifth A, 5 indicates its valency electrons. For example, go for what? 7th A group element. 7th A group elements will have NS2 NP5 configuration. NS2 NP5. Now valency electrons are how many? 2 plus 5 is equal to 7. It is a 7th A group actually. Fluorine will have 2s2 2p5. Chlorine will have 3s2 3p5. Bromine will have 4s2 4p5 like that. If lastly, if you what happened? 8th A group element, the NS2 NP6. Now 2 plus 6 is equal to 8 electrons. 8th A group element it is, isn't it? Except helium. Helium is having something different. It is having only 1s2 configuration. Remaining, if you observe what happened, it is having 2s2 2p6. Isn't it? Like that you are having configuration. Now 0, because why they are called 0 group elements? Very simple thing. These elements are having electron affinity will be 0. The electron affinity for these elements is what? 0. That means they don't take electron. Their affinity towards the electron is what? 0. That is the reason they are called 0 group elements here. So I have completed what actually here? Groups. Now I have completed here different types of the group numbers here. According to the modern periodic table, 1 to 18. According to the Mendeleev periodic table, 1A to 8A. Similarly, what happened? 1B to 8B. So, for example, B, if you observe, 1B. 1B will have 4s1 configuration, outermost shell. 2B will have NS1. I'm writing NS, sorry, NS1 configuration. This will have NS2 configuration. If you write zinc configuration, go for zinc configuration, copper configuration. Copper configuration is what? Abnormal configuration is what? 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s1. Now the valency shell is having how many? 1 electron, 1b. For example, zinc will have 4s2. Now valence electrons are how many here? 2. Therefore, it is having 2b group actually, right? So this is about the periods and groups. Okay, you need to.
Sir, what does A and B indicate?
A and B indicate they differ. What happened? Their d orbitals. In B group, what happened? In addition to the valency shell, inner shell also will be filled. For example, what is the configuration of calcium beta? Calcium configuration. Calcium configuration I'm writing here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Okay, this is the valency shell. Now, what about the scandium or anything? If you take any B group, you take titanium, anything you take. But I have taken what? Titanium I have taken. Titanium I am taking. Okay, this one, this titanium I am taking. Now, configuration will be again 1s2, 2s2, 2p6, isn't it? Here I am writing 2p6, 3p6, 4s2, and 3d2 here. Now, what is the valency shell here actually? Tell me. Valency shell is 4s or 3d. In this case, B group, what happened? Electrons will enter in the inner shell. Inner shell is nothing but here 3. Outer shell actually here 4, but electrons are how electrons will enter? Above principle. According to Above principle, 4s is what actually lower energy than the 3d, which is more which is energy. If you observe what happened, 3d is what? More energy when you compare with 4s. So after filling the electrons in the 4s, electrons will fill in the 3d orbital. Inner shell it will. So they are given what happened? B. Isn't it? Then actually ns to n. After filling ns, they are moving for np only. So they are given A here. Here they are given B. Because in this B section, what happening here? Electrons are entering in the inner shell. In the A section, electrons are entering in where? Outer shell. That means n orbital there. In this case, which orbital is n minus 1? This one is the n minus 1 orbital. Okay. So this is about the shall everything will be now it will come here. You observe clearly it will come. You can watch now. Right. Okay, this is about the first year, second year, everything is no. This is about you are easily visible for you. Okay, this is already 113. No, let it there it is. Now here one thing. What about the hydrogen now? What about the hydrogen? Hydrogen belongs to which period, beta? Hydrogen belongs to which period? You are not listening.
So first time.
If you don't
So
answer,
first-
I will take answer class up to 4 o'clock, isn't it? Because I have had my lunch completed.
Period.
Up to 4 o'clock, I will take the class.
Sir, first period.
Yes, first period. Very good. What about which group it is?
First.
First group it is, but it is not there. First group it is there. You see, observe this from periodic table. First group elements are what? Lithium, sodium, potassium, rubidium, cesium, and francium.
Say 18th group.
18th group is the 18th group. This is the 18th group. Here hydrogen is there here. It is helium, no? It is helium it is. Hydrogen group number is uncertainty. We don't have group number for the. If you observe here, you just open your textbook. In the textbook, we study the hydrogen in a different chapter actually. And first A group is different actually. So hydrogen does not belongs to first A. It may exhibit same properties like first A, but you can't place hydrogen first A, or even hydrogen you can't place in the 0 group, or even you can't place hydrogen in the 7th A group, or even you can't place hydrogen in the 3rd group element. You can place in first A, you can place in the 7th A, or you can place in 3rd also, because it resembles it resembles with first A, 7th A and 3rd A, but you can't place the hydrogen. So what I am saying here, hydrogen position is still uncertain. So that is the reason separately it is placed. But some periodic table they placed here. If you observe some of the periodic tables you are having at home, they are placed here, but the position is uncertain. You can't place on the first A group element. Now let me take the IUPAC nomenclatures. IUPAC nomenclature. How to give the IUPAC nomenclature? IUPAC means what actually? International Union of Pure and Applied Chemistry. Is it a full form? Okay. So nobody asks full form in the examination. Leave it that way. Now the groups are numbered 1 to 18 in accordance to with IUPAC norm. What are the recommendations? What are the rules for IUPAC nomenclature? Let me see now, isn't it? Now one more thing. This is actually this number you are getting no. So in according to IUPAC nomenclature, shall I use first A or first group? This nomenclature I have to use or this nomenclature? This is the IUPAC nomenclature. This is the IUPAC method actually. So writing 1, 2, 3, 4, 5, 6 is IUPAC nomenclature, and writing the Roman letter is not IUPAC nomenclature. Writing the Roman letter is a Mendeleev old nomenclature there actually. Periodic number is equal to highest principal quantum number of the element in the period. This is the note for you. So if anybody asks you, isn't it, what is its periodic number, just to go for what? Highest principal quantum number. Highest principal quantum number is nothing but the periodic number. I will give explanation for this one. We'll take one example. I'm taking the scandium here, okay? I'm taking the scandium. Now write the configuration of the scandium here. I'm writing here. Scandium configuration, I'm writing here. Scandium configuration will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d1. Now tell me which is the highest principal quantum number in this one? Highest principal quantum number. Do fast. Highest principal quantum number. Highest number.
4. 4.
What about remaining one? This is the highest principal quantum. 4. N is this is n only, no? So highest principal quantum number is a 4. Now 4 is nothing but it's a periodic number. Period number, sorry. It's a period number. So if you know the electronic configuration, if you write electronic configuration, whichever is the highest principal quantum number, that will be its period number. Okay, you can easily identify its period number. Okay, that is I am mentioning. Simple or not? How to identify the period number? Very simple. Write the electronic configuration. Wherever you get the highest principal quantum number, that is the period number, right? Some important points of the modern periodic table. Let me see. First period contains how many elements? See, 2 elements. Let me see again the periodic table. How many elements you are having in the first period? Let me see that. Let me check everything. How many periods? Already I told you this how many elements are there, but again let me see this. Check this one. Now this is the first period. How many elements are there? Hydrogen belongs to first period and helium belongs to first period. So total here 2 elements. That is the reason it's called shortest period. So first period is called what? Shortest period. This is called what? Shortest period. How many elements they are having? Only 2 elements they are having. The remaining periods, if you observe what happened, second is having 8 elements, third period is having 8 elements, fourth is having 18 elements, fifth is having 18, and sixth and 17, the seventh they are having 32 elements. So this already I discussed, sixth and seventh, how they are having 32 elements. Already we discussed this one. If you observe the periodic table, you will get this one. And this is having how many here? 8 elements. See, 1, 2, 3, 4, 5, 6, 7, 8. You also having 8. 1, 2, some. You count that one. You just observe the periodic table. You will get that one. Okay. So this is about the elements having in the different period here. Shortest period is what? First period. Next, what happened? Second period. First, after second, third, fourth, fifth. Second having how many? 8. Third having how many? 8. So these two called short periods. These two called short. And fourth is having how many elements better? Fourth is having how many?
18.
18.
18 elements. So it is called what? Long periods. And already you know 6th and 7th having 32 elements.
32.
They are called longest elements. So what I mean to say is that longest period is nothing but 7th, which include 32 elements. Long period. Long contains 18 elements. They are nothing but 4th and 5th periods. Short contains 8 elements. They are nothing but 2nd and 3rd period. And shortest period is what? First period containing only 2 elements. So remember this short, shortest, long, longest here. Okay. Seventh is incomplete because of using what? This unknown nomenclatures here. Lanthanids will have, this already we discussed this one. Lanthanid belongs to 6th period. Actinide belongs to 7th period. And each one will contain 14 elements. And they are placed below the main periodic table. You know that one already. We discussed this one already. Now observe something about table here. First period. What elements we are having? Hydrogen, helium. Second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Total how many? 8 elements. Third period, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. Also having again 8 elements. Fourth period contains potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenium, selenium, bromine, and krypton. Containing how many? 18 elements. Here 8, here 8, here it is 2. Next. Fifth period contains what happened? Rubidium, strontium, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver, cadmium, indium, tin, stilbene, tellurium, iodine, and xenon. Next, what happens? Uranium, osmium, iridium, platinum, aurum, gold. Aurum means what? Gold, mercury, thallium, lead, bismuth, polonium, astatine, radon. This is also called plumbum. In plumbum. Seventh period is incomplete. This one. And one more thing. This lanthanids comes under which period here? Sixth period. Okay. Lanthanids comes under sixth period. Next. Seventh period. Francium, radium, actinium, rutherfordium, dubnium, sagarium, borium, osmium, meterminium, thermostanium. This one, what happened? New elements are there. We'll discuss these IUPAC nomenclatures. All these IUPAC nomenclatures we will discuss in the next slides. Okay. This again, actinides comes under where in the seventh period, isn't it? Thorium, protactinium, uranium, neptunium, plutonium, americium, America, and the name of America, americium, curium, Madam Curie, berkelium, californium, einsteinium, fermium, mendeleum, Nobel medal, Nobel award, nobelium, and lawrencium. So these are the elements we are having. So here again 18, here it will be 32. Here it will be 32 elements. What is the difference between approaching the Mendeleev and modern periodic table? Atomic weight we use in the Mendeleev, atomic number we use in the modern periodic table. This is the difference is there in the. This one is atomic number. This this already we'll discuss that one later. The period that contains only gaseous elements. Do you know this one? Which period contains only gaseous elements? Yes.
First.
Hydrogen, helium, both are present in the first period, and both are what actually? Gaseous elements here. Hydrogen and helium. Right? The period which includes all types of elements. All types means what happened? Solids, liquids, and everything like that. Isn't? Which period do you know this one? Sixth period. Okay, which contains all types of elements. This one. Is longest, shortest periods? Tell me. You know this one. No need. This is the longest and shortest periods. Isn't it? Already you know this one. Now tell me which family it is. Now tell me answer for this one. Atomic number of nitrogen is 7. Okay. Atomic number of nitrogen is 7. Atomic number of the third member of the same family will be. Okay. So how to answer this one? The atomic number of the same group. So whatever the nitrogen present, the element of the group of nitrogen, okay, of third member. That means, for example, I am writing nitrogen. Okay. Next, phosphorus. What is this X they are asking? This is the first member. Which family it is? 15th group, no? 7th A group or 15th group. But what they are saying, its atomic number is given 7, right? Its atomic number is given 7. Now, second member in the family will be phosphorus. Third, they are asking, what is the atomic number for the third? Third is actually what happened? Arsenic. Okay, X I have taken, but X means what? Unknown element. I have taken arsenic. Okay, now they are asking what is the atomic number of this element. Understood my question here? The third member of the nitrogen family. Yes? First.
So C option is correct.
How you got the answer? How to make the answer? Now tell me. If they give atomic number of element of the group, how to identify the element atomic number of element of the same group? How to give that one? What is the answer? In that case, you need to remember some magic numbers. What are the magic numbers? 2, 8, 8, 18, 18. Finally, what happened? 32. Where you got these numbers? Can you say? 2, 8, 18, 32. Where you got?
So number of elements in that.
First period contains 2 elements. Second period contains 8 elements. Again, third contains 8. Fourth contains 18. Fifth contains 18. Sixth contains 32. That means when you move to from first to second period, you have to add +2. Okay. When you move towards second to third, you have to add 8. Similarly, when you move toward fourth to fifth, like that, you have to add elements actually. So what I mean to say here, so again, I'm writing here. So nitrogen, phosphorus, arsenic. Now, nitrogen belongs to which group better? Which period better? Nitrogen belongs to first period or second period? Nitrogen belongs to first period, second period. Do fast.
Second.
Second period. Okay. So when you move to second to third period, how much you have to add? +8. Understood? This one. +8. Okay. When you move to what again? Third to fourth period, how much I have to add?
8.
+8. +18, sorry. +18. Isn't it? Now tell me here. Atomic number of nitrogen is already, we know this one, 7. Okay. From this you start from this you start here. Because first to second also there no. In that first to second you add what happened? 8 actually. So that is also there. No. First, because we don't have first here. So first to second period, how much we have to add? 8. Second period to third period, how much we have to add? Again 8 only. Again third period to fourth period, how much you have to add here? 18. If you move toward fourth period to fifth period, how much you have to add here? Again 18 only. When you move toward sixth to seventh, how much you have to add? 8. This if you remember, this table if you remember, you can give answer very simple. So when you write from first to second period of same group, remember this is for same group. This is for same group only. Okay. First to second period 8, second to third period 8, third to fourth period 18, fourth to fifth period 18. This one 32. Sorry. Okay. In this way, we can write these are the magic numbers we can use for writing the atomic number. Now tell me, you are moving towards second to third period. What you have to take? 8. Moving to third to fourth period, what you have to add? 18. Okay. Now 7 plus 8. How much it is? 15. Next 15 plus. How much I have to add? 18. How much it will be? 33. So answer will be 33. Understood? For example, I will take one more example. We'll take it. I will take what happened. Fluorine I will take. Okay. Atomic number of the fluorine 9. I want the fourth member. Fourth member is nothing but what? Chlorine, bromine, iodine. Fourth member. This is the fourth member, not period it is. It's a fourth member. Now it belongs to which period? Fluorine belongs to second period. Okay. Chlorine belongs to third period. Bromine belongs to fourth period. Iodine belongs to fifth period. Now how to make atomic numbers here? Now moving second to third. How much I have to add? Tell me. Second to third period, how much I have to add?
8.
8. Definitely
8.
Here, 17. Moving to third to fourth period, how much I have to add?
8.
18. 18.
18.
Observe this table better. You have to observe this table. Easily you can identify. Okay. So you will get how much here? 35. Fourth to fifth, how much you have to add? Again 18 only. You add plus 18 here. Right. Atomic number I am writing here. 30. Now fourth to fifth period, how much you have to add? Again 18 only. How much we get here? Reverse to this. Bromine atomic number is 35. No. Reverse that one. 53. Easily you can remember. No need to add 18 like this. Bromine atomic number is 35. Reverse that one. How much we get? 53. That is atomic number of iodine. So what I mean to say is that what happened. You remember this table. Same group. You can write your atomic numbers very easily, isn't it? So answer will be 33. Now you do and you take after the class. What you do actually? You get all the elements of the group actually. For example, I will do one. Take this example: lithium, sodium, potassium, rubidium, cesium, magnesium. Now find out the atomic numbers. I am giving the atomic number for the lithium. I am giving 3. By putting what happens? Plus 8, plus 18, plus 18. Sorry, plus 8. Plus 8, plus 18, plus 18, and plus 32. Isn't it? Which period is second period? Second period, third period, fifth period, seventh period. Now you will get atomic numbers, everything for the sodium you will get, potassium you will get, rubidium you will get, cesium you will get by adding plus 8, plus 8, plus 18, plus 30.
17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. 7, 2, 4, 5, 6,
What you are doing?
7, 8. 87.
Who is that mathematician? कौन है वो? मैथमेटिक्स कर रहे हैं? Understood? Right. We'll move to our next slide now. Okay. Next slide over. We'll do last one is there. I will take that one in the 2-3 minutes only. We complete that one. Okay. That will also will complete now. Nomenclature. Nomenclature is a simple topic. I will complete that one. Only nomenclature only. After that, next we will see that one. In 5 minutes, we complete this one. Only 42 students are there now. 61 is strength, I think 60, 18 are absent today. Nomenclatures, let me see now. Nomenclature of elements with atomic number greater than 100. This is in this you will get some questions in examination. So all of you do carefully here, listen carefully and do exercise also now. How to give the nomenclatures for here? Very simple here. Now for each digit we get a nomenclature. If you have a digit 0, the name you have to call nil, N-I-L, nil, and abbreviation small n, right? For 1, U. For 2, by, B. First letter only we have to take. For 3, try. Then T. For 4, quad. Don't take tetra. Why they are not taking tetra, you know? Already T came, no? So don't take tetra. T already came, no? So that is the reason what happened. They taken quad here. Quad means what happened? Q. First letter only we have to take here. Very simple. First letter. N, U, B, E, Q like 5, tent, P, 6, X, H, 7, don't take hept, take sept. Hept you take what happened? No, already H is completed. We have taken H already, no. So don't take H again. That is the reason don't take hept, take sept, S, 8, oct, O, 9, N, isn't it? N. Non don't take. Non generally for 9 only, but nil already came, no. N already came, no. Take for N now here. E. Okay. So for 0, tell me. For 0, all of you.
Nil.
For 0,
Nil.
nil. Symbol will be
N.
symbol.
N.
For 1,
N.
symbol
N.
Un.
U.
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 2. Next,
By.
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 B.
symbol
B.
B.
for
B.
3,
Try.
for
Try.
4,
Right. Quad.
for 5,
Hard.
6,
Hex H.
7,
Sept
Step
S.
S.
8,
Oct.
O.
O. N.
9.
E.
In.
N.
Now, all of you remember this one. In
N.
examination,
E.
definitely question from this topic. The chance of getting question from this topic, the chance is there. So if you remember this one only, we can make IUPAC nomenclatures for any element after the, isn't it, 99. From 100 onwards, we can give the numbering in this way actually. We'll take some examples here. 101, you are calling unnil anium. Unnil anium. 102, unnil bium. How you are calling, let me see. So 101. 101. 1 means, you know, what is that 1? Tell me. 1. For 0?
Nil.
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 For 1 again? 1. And all will get a suffix called IUM. All will get this one. All are getting, you see, All are getting So you have to call now unnil anium. See, Un for what? 1. Nil for what actually? 0. Un for what? 1. Again, un for what actually? 1. We are getting for all the cases here. This is for all the cases. You take for 102. See, un, 1. Nil. They didn't written here nil. You write here nil here. Okay? Nil. 0. By means what actually? 2. 102. Again, you take un, 1. Nil. 0. Try. 3. Again getting it here. Here I can try. Okay. Next what happened? You take last. This one you'll take. 1. Nil. 0. Oct. 8. We get for all the cases here. Okay. So you take 106 you take. 1. Nil. 0. Hex 6. We get all the cases. 106. Symbol, how you write? You see, For un, U symbol. For nil, N symbol. For eggs, S symbol. Okay. Official names are different. Official names are different. Official name is depends upon how they are origin. Otherwise, what happened based upon the scientist. So that is a different criteria. So 105 dubnium we call, but IUPAC nomenclature will be un, nil, pentium. Un, nil, pentium. Okay. In this way, we can write any number of nomenclatures. Official nomenclatures will be given differently, isn't it? Now, what will be the, now tell me what is the answer for this one? 120. For 120, which option is correct one?
Sir, D.
Study.
1 means what? U. 2 means what? B. Next, 0 means what here? N. UBN. UBN is where? D. What is the nomenclature? Un. Next, what happened? By. Next, what happened? Nil. Next, what happened? Isn't it? Un, bin, B, nil, In this way, we can give easily answer here. In this way, we can solve very simple. In this way, if we solve what happened, you will get the answer here. See, un, by, nil, plus Okay. Un, bin, nilium. Abbreviation will be UB. Generally, what happened? The first letter should be capital letter. Okay. The first letter should be what happened here? Capital letter. It should be what happened? Capital letter. UBN. Okay. Now, what is the atomic number? By seeing the symbol, can you say atomic number for this one?
That's B.
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 U means what? U means 1, U means 1, U means 1. Triple 1. Okay. Fancy number. Triple 1 we got right. It is Rondini. Official name is Rondini. This is actually what happened. This, if you see that period table, you will get this one. Okay. Has in here. Now, this is only we'll discuss today. Today also, tomorrow also, I will post the time. After that, if you get the timetable, I will take class at the timetable. Otherwise, I will post the time. Okay. Next class, we'll see the electronic configurations and everything. So this is about the today's class. So what we discussed today? Can you say what we discussed today? Anybody? What topics we have completed today?
Groups, periods, name, nomenclature.
We have discussed about the modern periodic table. Okay. Now, in that, what you have to remember statement. The periodic, the physical, chemical properties of the elements are nothing but periodic functions of their atomic number or electronic configuration. This statement is very, very important. Then after that, how many periods are there? How many groups are there? Okay. And what are the elements you're having? And what are the periods you're having? Short periods, long period, like that we have completed. Then after that, what happened? And different type of groups also we completed according to IUPAC nomenclature and normal Mendeleev periodic table nomenclatures. And how to identify the group number, how to identify the atomic number by using the magic numbers. And finally, we completed the IUPAC nomenclatures for the elements after 1990. Okay. Now, I will post something question. Otherwise, you do one thing. You open your NCERT textbook today. Read the textbook now up to IUPAC nomenclature. Whatever there up to IUPAC nomenclature. Don't read what Mendeleev periodic table. Start from where? Modern periodic table. Read from modern periodic table only in textbook. And if you have any exercise on that, definitely we have exercises are there on the IUPAC nomenclatures, and complete that exercise. Okay. If you have any doubts, you can ask me now. Otherwise, you can leave. And one more thing, how many of you completed that science project? This is that. Kalpesh
So what
is
is
there.
the due date?
Kalpesh is there. Kalpesh. Saturday, ना सर? Science project का. अभी you will get 2 or 3. Just take 2 or 3 days. 2 days. Okay. 2 or 3 days. You need to finish that. Kalpesh, what?
Then where will the exhibition will be conducted? Means in
School only.
or
School
live
only. Right now in school only. First in school level. Then whichever selected, they will go regional level.
Some means mode of exhibition, sir. Like we have classes online, so exhibition will be like that, or we have to come to school.
Actually, it is in video mode only. But what actually that will decide first of all, after discussing with principal sir, whether in school, generally in the region level, it will be offline, online only. In region level, online only, completely online only. You have to make a video, short video, 1 or 2 minutes only, not more than 1 or 2 minute video duration. And just